All right, just looking at number 19 from the homework. This is an engineer determines the angle of elevation from her position to the top of the tower is 52 degrees. She measures the angle of elevation apart 47 meters farther from the tower, and the angle of elevation is 31. Both are due east of the tower. Find the height of the tower. Okay. Kind of tricky. But okay. Make that the tower right there. All right, and we have one angle of elevation to the top of the tower at 52 degrees. And if we go a little further out, extend that, second angle of elevation of the tower is 31 degrees. And this is 47 meters between these two. All right? The question is, what's the height of the tower? What we had to do is think a little bit creatively here. I'm going to call this distance, this initial distance from her to the base of the tower, x. I mean, you think here's the way, what makes this problem kind of frustrating, because, well, gosh, if you measure this is 47 meters, can't you measure this distance and make life a lot easier for everybody? Apparently not. There must be an uncrossable moat filled with sharks and alligators in between them and there, so that must be the problem. That's why they couldn't measure that distance, right? Okay, no problem. So I set up tangent of 52 is opposite. Okay. This distance, whole distance here, is x plus 47. So tangent of 31 equals h over x plus 47. Okay? Now from this, then I can go ahead and do, since I have two equations and two variables, I can do a substitution and solve this. So what I would do, it's probably easiest to solve for h here. H is x times tangent of 52, right? You with me so far? Multiplied this equation through by x to get that. So tan 31 equals x tan 52 over x plus 47. Isn't that fun? But at least I have just one variable now, so I could multiply both sides by x plus 47 times tan 31 equals x tan 52. And now we really get to, once we get here, I think you start seeing the algebra. X tan 31 plus 47 tan 31 equals x tan 52. Bring the x's to the same side to get 47 tan 31 equals x tan 52 minus x tan 31. And finally, we can factor out the x's. And I get x equals 47 tan 31 over tan 52 minus tan 31. Yay! That's why that's a C-level problem. Okay? Yes.
I think it's too difficult.
You've got an easier way?
Yeah.
How'd you do it?
Okay, I've calculated one thing.
Yeah, sure.
I calculate this way, and then I
Oh, okay, but we don't have a way of calculating this
Yeah.
off this triangle. You've probably used something. You use law of sines?
Yeah.
Oh, okay. We'll learn that next chapter. He's right. That is an easier way. Okay? If they're doing it, it would be easier. But we don't learn that stuff till next chapter. He's a little ahead of us. The German educational system beating us again. What can we do? Anyway, right now, this would be the only way we'd have of doing it. And once we solve for x, then I can easily solve for h. Once I know that that value is for x. And of course, that's going to be a real pleasure to put in my calculator, even 47 tan 31. 47 tan 31, parentheses, equals, divided by, and I'm going to put in parentheses, tan 52 minus tan 31. Parentheses, minus tan 31, parentheses. Likely not, maybe as a bonus type question. That's definitely an extension type question. It winds up being 41.6 meters. And once I have that, then I could just substitute into here very easily. And h equals that times to tangent 52. Oops, times tan 52. 53.2 meters. For the tower height. But that's just, that's just algebraic manipulation of an equation. Get used to that sort of thing. Lots of manipulation, lots of rewriting and reformatting and factoring and that sort of thing. That's calculus for you. You do a lot of that. Actually, in calculus, that's a really short one. So, it is more complicated, though. I mean, that is definitely the high-level problem. That's hard. So let's talk about navigation. I'm going to switch the slide order here just to, oops. I want to put that first. There we go. All right. Navigation is tricky, not because it's hard in and of itself, but because it uses a completely different measurement system than what we're used to. We're still using degree measurement, we're still doing everything, but in navigation, we're used to the positive x-axis being our initial axis, that's 0, and rotating counterclockwise for positive measure. Navigation does it completely differently. 0 is due north, and we rotate clockwise for positive angle measure. So just to really mess you up, that's why I said this is going to kind of irritate you a little bit, in that the angle measures are completely different. If I say a 220-degree angle measure, you're used to saying, oh, 220, that'd be a little more than 180, that'd be down here. Now all of a sudden 220 starts here and comes around here and is over here instead, because of the clockwise rotation. So we're going to have to deal with the fact that we're dealing with a completely different way of setting up standard position, what we consider to be standard position, when we're dealing with a navigation problem. And when they talk about a direction in navigation, it's often referred to as a bearing. So a ship is bearing 215, that means they're on a course of 215 degrees, which would be a little bit west of south. They could also use other descriptions like they're 30 degrees east of north, or north 30 degrees east. That would be north 30 degrees east. Or they could say west 10 degrees south. So there'd be west and 10 degrees south. That'd be west 10 south. So all sorts of different ways we have of noting direction in navigation. If you see something like this, W10S, west is your initial axis, and it tells you how many degrees and in which direction to move. It's actually very descriptive. It's just kind of a different way of doing it. So anyway, just be aware of that it's a different measurement system. It's a different way of setting up our angles and things like that. I put that next thing. South 15 degrees east. Okay. So if I said south 15 degrees east, then what would be the bearing for that? What would be the actual compass direction? Bearing being compass direction? Well, 0 would start here. At 0, clockwise, how many degrees is that? If it's 15 degrees right here, that'd be, 165. So the compass bearing for that, south 15 degrees east, is 165 degrees. So if it's a bearing 165 or south 15 east, either way we're getting the same motion, the same direction. Because bearing has everything to do with direction, and navigation is all about direction. Now, most of this navigation stuff, obviously, with the advent of GPS, is pretty much outdated. Because now we just punch in our GPS where we want to go, and it does it for us, right? Even tells us where to turn, or if you're in a ship, it'll tell you which direction, if your compass is on the right bearing or whatever. It'll tell you. So, again, a little bit old-fashioned, but about 20 years out of date. That's not 200 years out of date, at least. Still useful to do. I mean, if all the electronics suddenly fail, electromagnetic pulse destroys everything, you may have to navigate someday. This could be useful. Maybe. Pilot is traveling on a bearing of 36 degrees and sights Milwaukee's at Mitchell International Airport. His line of sight forms a right angle with the airport and the plane's line of travel. Find the bearing of the airport. Very typical problem. All right. So, basically, we have a situation like this. I start out with just a little north, south, east, west crosshair usually. All right? Actually, I'm going to move that down here. The pilot is on a bearing of 36 degrees. So, that means this is 36 degrees. Okay? And this is going to represent my airplane right here. That's the bearing that he's on. 36 degrees. The pilot's line of sight forms a right angle with the airport and the pilot's line of travel. So, the pilot is right here, and it forms a right angle with the line of sight. Now, you're saying, well, is the right angle off to the left or to the right? Well, which side does the pilot sit on? Which would be the right angle. Probably assume the pilot is sitting on the left, just like a driver in the United States. We aren't in Great Britain. If we're in Great Britain, then we'd have problems. Okay. So we'll assume it's to the left, forming a right angle there. And it says find the bearing of the airport. Where's the right? Oh, I'm going to the next level of problem here. I'm thinking I might be overthinking this. Hold on. Sites Milwaukee's International Airport. Oh. I'm overcomplicating this. Why am I overcomplicating this? I think I know what I did. Okay. I'm sorry. I overcomplicated that. I was going to the next level of bearing problem too early. Basically, this is even simpler than that. Having a bearing at 36 degrees. Sites the airport. So here's the plane. Okay, the 36 degrees is here. Yep. Yeah, I way overdid that. Sorry. I did take you to the next level. Back up for a second. Let's just start with the plane as a dot. Okay? The bearing of the plane is 36 degrees. Okay, there's my 36 degrees. The airport's at a right angle. What would be the bearing of the airport? Well, since it's at a right angle, this is 36, this is going to have to be 54 degrees to add up to 90, right? The bearing of the airport is going to be from north, however. So the bearing of the airport is going to be 360 minus 54 because it's going all the way around here, or 306 degrees is the bearing of the airport. Sorry, I overcomplicated that first one. That's all we had to do here. So all we do is we indicate from the airplane, the bearing of the airplane, the bearing of the airport. Together they form a right angle. Since this is 36 degrees, the right angle, 90 minus 36 is 54. That's 54 degrees towards the west of north. But the bearing is measured from true north, so I have to rotate around to that 54 degrees, giving me 306. So that's one of the type of bearing problems we're going to see today. And like I said, I apologize, I overcomplicated that to start with. A tugboat starts in a course of the lighthouse at a right angle to its bearing. After traveling 45 minutes here, now we're getting into what I wanted to do. Okay? Because now we're getting into vectors. And for those in physics, yes, vectors. Good times. Tugboat starts in a course of the lighthouse at a right angle to its bearing. After traveling 45 minutes at 28 kilometers at a course of 30 degrees, the tugboat finds a new bearing to the lighthouse of 214 degrees. How far is the boat from the lighthouse? Here's where we need to start. Okay? Here's my starting point. Tugboat starts here, is on a bearing of 30 degrees, and sights a lighthouse at 90 degrees, at a right angle to its bearing. Okay? So this is 30 degrees and this is 60 degrees. There's a lighthouse over here somewhere. I don't know where it is, how far it is, but it's over there somewhere at that angle. Okay? After traveling 45 minutes at 28 kilometers per hour. Okay, if we go 45 minutes at 28 kilometers per hour, how far have we gone? Distance, rate, time problem, very quickly. 21 kilometers, right? 3/4 of an hour, 3/4 of 28 is 21. So after going 21 kilometers, the tugboat is here, and now the bearing to the lighthouse, when he looks back to see that, is 214 degrees. How far is the boat from the lighthouse at this point? What's this distance? Now here's where it gets interesting. Because essentially what we have in here is a right triangle. There's a right triangle. And I know with my right triangle, let's kind of re-sketch that right triangle. Okay, I know at this right triangle that this is the side is 21 kilometers, right? Because that's the path of travel of the boat. That this is my right angle down here. What I need to do is I need to find one of these two acute angles. Now, what I want to do is this is where it gets interesting. And here's where we have to be kind of puzzle solvers on these bearing problems. What I have, and I'm going to enlarge on another screen here, this little drawing. If I look at the initial course of the boat, I'm enlarging it now, and here's another north, south, east, west. Okay, we said this was 30 degrees, right? So, because of alternate interior angles, back from algebra, remember the N shape or the Z shape for alternate interiors at all? This is still north-south, this is still north-south. This angle and this angle have to be congruent. All right? They have to be. That's alternate interior angles with parallel lines. And if you have that kind of N or Z shape, that's what that means. That's one of the big tricks that we have to learn here for these types of navigation problems that involve vectors. We have that shape. The actual bearing of the lighthouse is 214 degrees, which is a little more because it's 180 to here, plus 30 would be 210. So this angle right here is what we're looking for. That's our unknown angle. Is going to have to be 4 degrees. And that's the puzzle you have to solve. What is that angle? Because it's pretty clear, going back here, that we have a right triangle from this angle, because it started out with a right angle. But now I know that this angle is 4 degrees. Now that I know that, I can find the distance to the lighthouse by just doing my trig. Because I have 4 degrees, I have hypotenuse, I have adjacent. Cosine of 4 is 21 over d, where d is 21 over cosine of 4. So the distance to the lighthouse, 21 divided by cosine 4. 21.05 kilometers. Not very far. Not much further. But like I say, the trick here is figuring out this angle in the triangle. Okay? Because initially the lighthouse, there's the lighthouse. All right? There's my fancy lighthouse. Figuring out that angle. And one way of doing that, like I say, is kind of making the intersections at both where the boat started and the boat finished. That's how I was trying to overcomplicate this first problem, is I thought I needed both of them, but I realize now that that was just the initial position situation. So we get our right angle, but we have to find this little bit here, because that's 214. And again, of that 214, this is 180. This is 30. That's 210. That leaves 4 degrees beyond that for that angle to be at. Yeah, that's weird, isn't it? That's kind of tough. Again, remember, this is like, the navigation stuff here is kind of like the simple harmonic motion stuff or the rotational velocity stuff. It's the stuff that gets people all upset. It's harder. People get all worried about it. And 70% of the quiz is what? 90% of the quiz is not this, right? Most of the quiz is just the basic solving triangles and stuff like that. But we do still want to spend some time on it. A little bit easier problem. A surveyor needs to determine the distance across the river if angle x is 50.5 degrees and the river and y is 415 feet. How far across the river? Should be y is 415 feet. It should be xy is 415 feet. Okay? So angle x is 50.5 degrees, and the distance between x and y here is 415 feet. How far across the river? Well, that's pretty easy, isn't it? See, we go from the really tough navigation problems to the really, really easy and accessible distance problems, which basically you just draw the triangle and do one simple trig equation and solve it. This is going to be what? Sine, cosine, or tangent to solve this? Tangent, yeah. So we go from the really difficult problems with navigation to the much easier problems with inaccessible distances. Most of the problems are the easier type tonight. Most of them are like this level. And this would just be tangent of 50.5 equals n over 415. And easy to solve for n from there. This is a very much more practical problem. We deal with this all the time. How do I find an inaccessible distance? We measure something we can and take a line of sight to do that. Typical surveying problem. The hip roof on a house consists of four congruent isosceles triangles with a common vertex that forms the peak of the roof. Think of a square-based pyramid. Each triangle has a base of 32 feet, and each base angle measures 50 degrees. Find the height of the triangles. Again, draw yourself a picture. Okay? Draw yourself a picture. Each triangle has a base of 32 feet. They're isosceles triangles. Each has a base angle of 50 degrees. Going to have to use a little of our geometry knowledge here because I don't have any right triangles in this picture, do I? But in order to find the height of the triangle, I'm going to create a right triangle, aren't I? And what happens in an isosceles triangle when we drop in the altitude like that? What do we do to the base? Because isosceles, we divide it equally, don't we? This is a bisector. So this becomes 16 feet, and this becomes 16 feet. So then it's pretty easy to find the height because, again, we use tangent. Tangent of 50 is opposite over adjacent. And I'll leave that little bit to you, calculating the actual height. So we have different types of problems in this section. I did the really hard one first. Well, second. Most of our problems are on this level. You might have to draw a triangle. In many cases in the book, they've actually drawn the triangle already for you. At least your number 8, they've already drawn the triangle for you. 11 and 12, they've already drawn things for you. Number 10, 9 and 10 are hip roofs. I've just given you that triangle. All right? So I don't think you're going to struggle too much. Don't panic about this one. Yes, that's the hard example. Kind of like, oops, hold on. Kind of like, this is a hard problem. But we don't ask, you know what the quizzes are like. We don't ask all the hard problems on the test. We ask a lot of very basic problems on the test. And only a few, and maybe one of the hard ones. Maybe two. So don't get too overly upset about the hard problems. Assignment for tonight. I'll put it up here. And again, I'm just going to be a little bit, I'm going to go 1 through 17 odd tonight. I don't know why, I'm just in a generous mood this week, I guess. But, I don't know, 1 through 18 just seems like a lot. 1 through 17 odd, I think, gets the point across. If you feel like you need more practice on things, by all means, do more problems. And check with me, and I'll give you the answers to them. But 1 through 17 odd, you can check your answers in the back. You can see if you're doing it right. You can ask better questions when you come back into class tomorrow. You know what you understand and what you didn't. Note that we do have a quiz coming up on Friday. We don't have anything new tomorrow. Tomorrow is just a review day. Should be pretty straightforward. Overall, I think it's a pretty easy week, with the exception of a couple tough navigation problems.
On my last quiz, I got 100, and you put in the grade book as an 80.
I'll look it up.
You still changed the first one to a 96.
Okay. First quiz. And the second quiz of...
Yeah.
I'll fix it.